The figure shows, two continuous waves P and Q traveling along a string. The wave P travels along the positive x direction and Q travels along the negative x direction. The string shape at a time t is equal to 0 is shown in the figure. The frequency of both the waves is 0.25 Hz. So the question is, from t is equal to 2 seconds and t is equal to 6 seconds, what is the maximum displacement of the superimposed wave at x is equal to 5 meter? So this is the figure that is given to us. This is P wave traveling along the positive x-axis and the other wave Q is traveling opposite to it. The amplitude of P wave is about 2 and in the positive and minus 2a in the negative side, whereas for Q it is half of that. So in this case we are going to find out what will be the, you can say, the maximum displacement of the superimposed wave. Basically means whether there will be constructive interference or destructive interference at x is equal to 5 meter here. Okay. So if we start from there only, that the traveling waves are in opposite direction. Okay. We say that traveling waves are in opposite direction. This is the first thing that is given to us, and the time is also given, that from t that is equal to 0 to t is equal to 2 seconds, both moving towards each other from opposite side. Both waves are moving towards each other. So we can find out the displacement of each wave. We can say displacement of each wave, if it is given as d will be equal to v multiplied by t, and the velocity of each wave is given as 0.5. So we get this as 0.5 multiplied by 2, and this comes as 1 meter. So it means at t is equal to 2 seconds, both waves will meet at x is equal to 5 meter, because each distance that we traveled in 2 seconds will be 1 meter. So both waves, both P and Q, will be traveling towards each other by a distance of 1 meter. So from here we can draw a conclusion, that means at t is equal to 2 seconds, both waves meet at x is equal to 5 meters. And now we are going to find out the superposition of the wave at x equal to 5 meter, which is supposed to be the question. Okay. So we say superposition of wave at x is equal to 5 meter from t is equal to 2 seconds to t is equal to 6 seconds. So for this we are going to use the simple equations for the traveling of the waveform, and we can write, first of all we start with the given parameters that are given to us. So we state wave propagation, and for wave propagation frequency f is given to us, that is our 0.25 Hertz, and wavelength is also given, that lambda is our 2 meters. So we can find out the propagation speed, that is v. So we can say propagation speed which is v, and that will be equal to our frequency multiplied by lambda, and that is 0.25 multiplied by 2, and this gives us 0.5 meter per second, and amplitude of p is 2a. Amplitude of p is 2a, whereas amplitude of q is a. Sorry. Amplitude of q is our a. So now let us make analysis of how the waves are going to behave by using the equations. So we say wave behavior analysis. So we can write the wave equations using wave equations. First we are going to write it for p. So we can say for wave p, we can write our y of p with respect to position and time will be equal to 2a sine of kx minus omega t, and for wave q we can write y of q with respect to position and time will be equal to a sine of kx plus omega t, where k is the wave number, and we can find out k is our wave number, and that is equal to 2 pi upon lambda, and this becomes 2 pi upon 2, which will be equal to pi. So wave number is our pi, and we can find out also value of omega, that is our angular frequency. Omega is equal to angular frequency, which is 2 pi f. We already know value of f, it comes as 0.5 times pi. So we can write both the equations, and the superposition takes place at x equal to phi. So we say superposition at x is equal to 5. Therefore the equation becomes for p wave, value of x is phi, t is equal to 2a sine of 5 pi minus 0.5 t, and we can use trigonometric identity, that is sine of a minus b, and open this equation, we get this as 2a, and we have sine of 5 5 pi cos of 0.5 pi t and minus cos of 5 pi, and we have sine of 0.5 t, and we know that sine of 5 pi is 0. We know that sine of 5 pi is equal to 0 and cos of 5 pi is equal to minus 1. So we substitute the values, we get our that y of p with respect to 5 and time t will be equal to 2a sine of 0.5 pi t. So this is one of the equation 1. Now similar analysis we can make for wave 2 q also. So we can say for wave q we get y of q 5t will be equal to a sine of 5 pi plus 0.5 pi t, and this also gives us, by using the trigonometric identity, this will be a, and we have here sine of 5 pi cos of 0.5 pi t plus cos of 5 pi multiplied by sine of 0.5 t. Once again, by using respective formulas, these values, we get that y of q for positions 5 and t will be minus of a sine 0.5 pi t, and this is our equation number 2. So total displacement will be equation 1 plus equation 2. Total displacement, let us call that is y total, yt at 5 comma t will be equal to y of p, sorry, this is 5 comma t plus y of q 5 comma t. So using equation 1 and 2 we substitute here. Using equation 1 and 2 we get y of t 5 comma t will be giving us 2a sine of 0.5 t minus a sine of 0.5 pi t. So this gives us that yt at 5 comma t, we get this as a sine of 0.5 pi t. And for maximum displacement, obviously the value of sine of 0.5 t should be equal to plus minus 1. So therefore we can say the displacement will be equal to a. Maximum value should be equal to a. So it means basically a destructive interference is going to take place. So we can say destructive interference takes place. So this question was quite simple, based on the value of the rather we can say equations of their respective wave P as well as wave Q. So this completes the question. Thank you.